Okay, so for this little problem here, you're asked to figure out which of these prices is more out of line with what's expected. And this is one of the big things, one of the big applications we learned last Thursday on how these statistics can help us make decisions. In business all the time, it comes up, you have to compare two things that may be more expensive than you expected or cheaper than you expected, and trying to figure out which one's the better deal or which one is more further away from what you would expect it to be. So looking at this problem here, we have family health care is known for being more expensive than others. X-rays are $950 with a national mean of 600 and standard deviation of 200. They want you to compare that to blood tests, which cost $280 with a national mean of, that should have been 230, sorry about that, $230 and a standard deviation of 25. Now looking at that, it's really easy to say, hey, the x-ray is $350 more than the national average. The blood test only $50 more. But the question is, how likely is it for each of those things to happen? And the tool we have to compare two things that come from different it would make sense that an x-ray would cost more than a blood test because it involves this big expensive machine. So we need to compare it back to its own population. So we use a z-score. And how do we calculate a z-score? Take the number, the 950 for the x-ray, minus the mean, which is 600. That would give us 350, yep. Divide by the standard deviation, which is 200, which gives us 1.7. So what that's saying is that is 1.75 standard deviations more expensive than the mean, higher than the mean. For the blood test, our z-score is going to be found by doing what? 280 minus 130, which of course would be 50, divided by 230, thank you, sorry, which is 50, divided by 25, which is the standard deviation, which gives us 2.00. Now I realize if you had like 6.00, that was my fault because I had a 1 there instead of a 2 on the 230 for a while.
Yeah, that's what I had down.
6.00, yeah, that was my fault. If you had that, you did everything correct. Either way, the blood test is actually more out of line. It's more standard deviations above the mean for the national average. There's my sound working better now. Did you guys follow that example? All we were doing was finding the z-score for each of them. And the one that, in this case, they're positive, so the one with the larger z-score, the larger positive z-score, is more above the expected price. So now here's the question. This is the blood test. I want to see if you guys can figure this out. What percent of healthcare providers nationally would you expect to charge more than FML? Take a look at that and see. This also ties in with something we did on Thursday, applying that mean and standard deviation. See if you can figure it out. We'll look at it in a couple minutes. So as we look at this actually follows that empirical rule we talked about, that bell curve. As you recall, that bell curve had the mean in the middle, and we went out 3 standard deviations on each side. And there were set percents that were in here. This was 34% here and here. 13.5% here and here. 2.35% here and here. And 0.15% here. Now the numbers that would go on bottom of this would be the national mean and standard deviation. So what would go in the center here? 230, the national mean. Now standard deviation of 25, so this would be what? $205. 230 minus 25, right? This one would be $180 minus another 25. And what's going to go here? What's that? $155. Good. Going this way, what's going to go here? $255, and here? $280 and $305. And of course, FML was 280, which fell right here. So what percent do we expect to cost more? To charge more than FML? Add those up, it's 2.5%. So FML is expensive, but it's not the most expensive. Any questions? Okay, so this last unit has been kind of a big one. We've covered basic statistics in the last couple of classes, and we've talked quite a bit about areas and volumes and geometry. So all that is left for us to do is to get ready for this lovely unit test coming up tomorrow. Do you guys have any topics that are giving you a particular amount of trouble? Okay, so let's just start going through it and see what we come up with. The first topic that we need to know for our test is going to be measurements. Oh, don't know what happened there. Let's try that again. And conversions, measurement conversions. So I'm going to give you a few problems to try. I'm going to have you try them, and then we are going to go over them. So let's see what you remember from things like this. Try those 8, and we'll talk about them in a minute. Okay, so for the first one up here, 64 pints. How many gallons do you get out of that? Anybody want to throw out their answer? 8. Perfect. Yes, because 64 pints, there are 4 quarts in a pint. So divided by 4 is 16 quarts. Or sorry, 4 quarts in a gallon. So divided by... Let's try this again. There are 2 pints in a quart. So divided by 2 gives us 32 quarts. And 4 quarts in a gallon. So divided by 4 gives us 8 gallons. Any questions on that one? Okay. 800 milliliters into liters, what'd you get? 0.8. Good. To get from on our chart, to get from milliliters to liters, it is 3 spots to the left. So our decimal point moves 3 spots to the left. Grams to milligrams. 0.37 grams becomes how many milligrams? 370. From grams to milligrams on the chart is 1, 2, 3 spots to the right. So we add the 0 to make it 370. 4.2 meters to centimeters. What's that become? 420. From meters to centimeters is 2 spots to the right. So we move 2 spots to the right to get 420. 96 inches into feet. How many feet is that? 8. Good. We divide by 12 from inches to feet. 54 cubic feet into cubic yards. How many cubic yards? How many cubic yards? Remember, 1 yard is 3 feet. If it's cubed, you got to cube that. What is 3 cubed? What is 3 cubed? It is 27, yes. So it's 54 divided by 27. That is 2 cubic yards. Anybody get that one right? 1? Nice. 1 out of 7 isn't too bad of an average. So anyway, 5 square feet going into square inches. What'd you get? 720, that sounds right. Because there's 144 square inches in 1 square foot. It's 12 squared. So 5 times 144 is 720. This one I don't know if we actually did before, but 1 gallon is approximately 231 cubic inches. So 8 gallons over 1. 1 gallon, 231 cubic inches. The gallons cross cancel. We've got 8 times 231, which is 1,048 cubic inches. What do you think? That's not right. It's 2,048, isn't it? I got a feeling it's going to be one of those days, and it's not 2,048. Let me try that again. 8 times 231. 1848. There we go. So it's going to be one of those days where mental math is not going to be done in my head for the day. 1848. Sorry about that. Any questions? Okay, so we struggled a little bit with the squared and the cubic, so make sure you look those over. I'm going to do a couple more here for you. Three cubic feet going into cubic inches and 7 square yards going into square feet. Try those quick. So for number 1, 3 cubic feet into cubic inches, what'd you get? 5,184. How many of you had that? Anybody have questions on how we get to it? 1 foot is 12 inches, right? This is cubic feet and cubic inches, which means we have to cube everything. 1 cubed is 1. Feet cubed is feet cubed. 12 cubed is 12 times 12 times 12 is 1,728. Inches cubed is inches cubed. So 1 cubic foot equals 1,728 cubic inches. So 3 cubic feet over 1. 1 cubic foot is 1,728 cubic inches. Cubic feet cancel out. It is 3 times 1728, which is 5,184. How about for the second one? 7 square yards going into square feet. 81, you're saying. 81? Something seems just a little off there. Sorry. 63 sounds better. I think that's what you were shooting for. You just multiplied wrong. 1 yard equals 3 feet. So when we go to square those, because it is squared, we're going to square it. 1 squared is 1, yard squared is yard squared. 3 squared is 3 times 3, so that's 9. Feet squared are feet squared. So 1 square yard equals 9 square feet. So 7 square yards over 1 times 1 square yard, 9 square feet. Square yards cancel out. 7 times 9 is 63. How you feeling about those? Better than a sharp stick in the eye? Not really. It's Monday. Yes, it is. Find those two correct. So complement means they add up to what? 90. Remember, it complements you when you're right. And a right angle is 90 degrees. So this should be 8 degrees. Supplement adds up to 180. So this should be 153 degrees. Questions? Okay. If I give you that this is 51 degrees, find this angle here. Anybody want to throw out their answer? 51? Okay. Let's take a look. From what we know, this is 51 degrees. What else can we find from that? Well, what do we know about this angle right here? It's 90. Because this one's 90, we're assuming these two lines are parallel, otherwise we can't do anything here. That has to be 90 degrees because that one's 90 degrees. Which makes these two complements. So this angle must be 39 degrees. If that's 39 degrees, this one must be 39 degrees. This one must be 39 degrees. Oops. Not 39%, 39 degrees. This one must be 39 degrees. which would make this one 141 degrees. Since this is 90, we subtract to get that this is 51 degrees here, making that one 51 degrees. And of course this one and this one as well. Not so bad. Find x and y. So for the first one, what do you get for x? 17 inches. Good. That one would be a squared plus b squared equals c squared. So 8 squared plus 15 squared equals x squared. Then you can walk the equation to get that x is 17. How about over here? What'd you get for y? 24. Good. Because you have a squared plus b squared equals c squared again, but now it's a that's missing. So it's y squared plus 7 squared equals 25 squared. Any questions? For this one, I want you to find the area and the perimeter. So, finding the area. Can we do 30 times 17? Not for area. Remember, for area, we have to have two dimensions that are perpendicular. We need to know this dimension right here. Can we find that dimension? How do we find it? Well, this is a triangle right here that we have with a right angle in it. If I call this x, it'd be x squared plus 8 squared equals 17 squared, which will solve out to x equals 15. So our area is 30 feet times 15 feet, or 450 feet squared. Perimeter, what do we do? Well, 30 plus 17 plus 30 plus 17, which is 94 feet. How many of you had both of those right? Any questions on those? You had the second one right. That makes sense. Yeah. Find the area and perimeter of this one. For area on this one, we're going to divide it into two main pieces. We have the rectangle and we have the half circle. How do we find the area of the rectangle? Well, we need to know this dimension here. How do we know what that is? Well, what is it, first of all? Well, what's this dimension here? 8 inches. Because it's 16 all the way across here because of this, right? So half of that gives us a radius of 8, which means this is a radius, that's 8 inches. This has to be 12 inches. It has to add up to 20. So that is a 16-inch by 12-inch rectangle, which is 192 square inches. For piece 2 there, that's half a circle. That area is pi times 8 squared divided by 2. We divide by 2 because it's only half a circle. Which gives us, well, like 100.48 or something like that. So that adds up to be 292.48 square inches. How many of you had that? A few of you on that one. Good, getting better. For perimeter here, we have these 3 sides. We need to know the length of this arc. So I'm going to find that first. The length of that arc is a circumference of a circle, but it's only half because it's half a circle. So that'll be pi times diameter, so pi times 16 inches divided by 2 because it's only half the circle, which is going to be 25.12 inches. So perimeter here will be that 25.12 plus the 12 plus the 16 plus another 12, which adds up to 65.12 inches. How many of you had that? Any questions? Okay, only one more problem that we're going to do, then we'll take our break, and then we'll come back and have some more fun. I think you guys get the picture. These are all in feet. I'm just going to throw numbers on here now. For this problem, I want to know the area. And so let's take a peek at this one. For area, what I would do for this one is this. I'd make it into a big rectangle. What's this dimension have to be? Not everybody at once. 19, good. 16 plus 3 makes 19. What's this dimension have to be? (26) plus 6 is 32 feet. So that makes the area of that whole thing 32 times 19, which is what, 288? Is that right? Yeah, 608. Wow, I'm way off today. I told you mental math is probably not something I should do today. 608 square feet. It's a Monday, you're right. So now we're going to subtract out this piece here. I'm going to call that piece number 2, which is just 3 feet by 6 feet, which is 18 square feet. So we're subtracting that. Then I have to find the size of this triangle. What's this dimension right here? That'll be 7 feet. And this dimension here, 24 feet. So that area is 7 feet times 24 feet divided by 2 because it is a triangle, which is 84 square feet. We subtract that all out and we get 506, I believe, square feet. Sound great? How many of you had 506? A couple of you? It's not too bad. Once you've found the area, the perimeter of this is a little bit easier. We have the lengths of all these sides to add up, except for that one. But now that we've drawn in that blue triangle, we can find this length. If I call that x, this would be a right angle here. It's just going to be 7 squared plus 24 squared equals x squared. And x would come out to be 25 feet. So my perimeter, if I start at the 25, is going to be 25 plus 8 plus 16 plus 6 plus 3 plus 26 plus 12, which all adds up to what? 96 feet. Anybody get that one? A few of you? Good. Well, that would be a good time to take a break. It is 10:14. Let's shoot for 10:24.